Okay, great. I think I guess I'm good to get going now. Let me share my screen. All right. Well, I hope everyone can see my screen because otherwise I guess I'm just talking into the computer. But yeah, hi everyone. My name is Fran. I'm a research lead at Tractable, and kind of welcome to my living room. And I'm going to talk a little bit today about kind of what Tractable does, and also how we kind of use deep learning and we use that to bring like real value to the claims process in auto insurance. So how we can take something from the lab, deploy it in the real world and make it really work, which I think is really cool. So start off with the statistics. I guess there are many data scientists in the audience. That 40% of European like AI startups do not use AI as a part of their business. This is according to a study done by like London-based venture capital firm MMC last year. When I saw this, I was very surprised, but you'll hopefully be happy to hear that Tractable is not one of those startups. Tractable really takes deep learning, takes AI, and uses that to bring a lot of value to our end users. So today I just want to briefly go through firstly what we do. So Tractable, very high level Tractable, accelerates accident and disaster recovery using computer vision. And then I'm going to talk a little bit about how we do it. So answering that question, how do you build an AI product that not only delivers but thrives commercially, which is really difficult, as I found out. So at a high level, what Tractable's products do is first step, you crash your car. Second step, you take some photos of it. Those photos are processed by an AI. The AI takes those photos, has a look, see what's the damage on the car, sees what you need to do in order to repair it and bring it back to the road. Then that AI estimate is auto approved by the insurer. And then you can get your money from the insurer, you can get your car repaired and you're back on the road. This is really cool. This process from kind of crash to cash, when done by humans, it can take weeks. When done by the AI, it kind of takes minutes, it can take hours. So this is such a huge saving of time, a huge saving of money. And the best thing is that you can get your car on the road quicker. You can have your livelihood back to the way it was before. And that's really what people need when they're kind of in these disaster situations. So how it works, you take your photos of your car, and then that goes to our AI. Our AI does two main tasks. Firstly, it does something called the visual damage assessment. It kind of looks at the photos and says, how damaged is this car? And then secondly, it applies a local repair methodology. So this depends on kind of which insurer you're with. It depends on what country you're in, depends on what kind of car you have. So given that damage, what do I need to do to repair it? And then combines those things into a full AI estimate, which is really cool. And it's like incredible how our AI can do this so accurately every time. To give a quick timeline of Tractable and like how we came to be in this amazing position, I guess kind of, so this, maybe if there are a few physicists in the audience who'll kind of empathize with this, but if you want to train an AI from scratch, you must first invent the universe. So 14 billion years ago, the universe was founded. Kind of shortly afterwards, Tractable came about in November 2014. Then shortly after that, which was like a very good breakthrough, I guess, for our business, that AI became better than humans at image classification in February 2015. After that, we started to develop our AI, and in early 2016, we made our first kind of AI damage classifier, which if you have a damaged front wing on your car, it will tell you whether you want to repair it or you want to replace it. So that was the first one. But obviously, it's no longer the only AI that we have. And we went live with our first customer a few months later. And then in May 2019, that's when we made our first full AI estimate, which is very exciting. And this is really kind of a step change in what AI can do in the auto insurance industry. And it's very thrilling to kind of be a part of that. I think the main question we had to answer throughout this, that I'm going to discuss a little bit, kind of my experience of answering this question, things I found work, things I found didn't work, was that how do you build an AI product that not only delivers, but thrives commercially, which is very different to how do I build an AI that I can publish? How do I build an AI that's interesting from an academic perspective? You have to optimize very different things. You have to think about your problem very differently. I think before I came to Tractable, I was a physicist. I did a PhD in physics at Oxford, which was amazing, and I loved it, and it was so much fun. But the thing that I always had in the back of my mind is that this is interesting to maybe like 20 people in the world. Those 20 people are really into it, but it didn't really have the sort of impact that I wanted. So I thought machine learning was cool. I taught myself from YouTube videos, and then a couple of years ago, I joined Tractable as a researcher. So the number one thing that I've learned from going from academia into this sort of like very applied, very like commercial AI setting, is you need to learn how to sell your research. So I do AI because I think it's cool and I think it has an impact, and I think it's great. This is very good if I want to kind of say persuade kids to follow my career path, or like persuade people to join Tractable. But it's not necessarily what you want to hear if you're a potential customer and you want to buy our product. So you always have to, when you're trying to solve a problem with AI in kind of in a commercial setting, you have to first think, what is the impact we want to have on the end user? Kind of, what do we want our product to do? How are we going to be helping people? And then secondly, think, what do we need to do in order to achieve that? And having that sort of customer first mindset rather than, I guess, sort of like a research first, is really kind of what makes Tractable so successful. So one example here is when I first started at Tractable, I was quite academic and I just wanted to do like the most cool and like obtuse and like super novel stuff. So if you have some photos of a damaged car, kind of the academic within me thought, oh, you can kind of make 3D models of the car. You can have like the super high tech where you can like scroll around the car and see a map of the damage across it. And it'll be really detailed and accurate. But actually, like, if you've crashed your car and you're kind of on the side of the road, I think the last thing you want is a nice 3D model of the damage on your car, because I mean, like, you're standing in front of it. So I think you can probably tell there's something wrong with it. Actually, what people want when they've crashed their car, they want to know how much it's going to cost to repair. They want to get that money quickly. And so always making sure you're super focused on the customer, super focused on what delivers the most impact to the end user, make sure that you build an AI product that is really good and really changes people's lives. I guess the second thing is that your AI will never be perfect, and that's okay. Kind of auto damage appraisal is complicated and difficult. It's hugely subjective. From person to person, it changes. Around the world, it's different. It's really hard. I'd say it's kind of arguably harder than the PhD in physics that I did, because kind of electrons are rational, humans are not so much. And so I'm, especially kind of as an academic, I'm very tempted to say I need to keep optimizing further and further, and I need to push for every like 0.1% increase in like accuracy or precision or recall. But there's not really a huge use to it if your AI is already very good. We kind of have a huge amount of challenges when we build our product. So generalization across car types. So this kind of, if we say want to kind of look at damage on the front bumper of a car, we have to answer this philosophical question of what is a front bumper? How do you truly define a front bumper? And then also multi-image reasoning. So obviously if you've got ImageNet, dog and cat, you just need one photo in order to kind of make an accurate classification. If you're looking at damage across the car, you need many photos. It's a set of photos that's not necessarily ordered. And that makes it a very difficult research problem. How do you learn the optimal way to combine information from multiple images? And then finally, the idea of a domain shift. So if you have a car crash in Japan, if you have an identical car crash in, say, the UK, your car will be repaired in a completely different way. This depends on a lot of factors, that is kind of labor rates, part prices, many different things. So how do you model this domain shift in kind of methodology, but also domain shift kind of in the visual appearance of cars? So in Japan, there are many box cars. In the US, there are many pickup trucks. How can you generalize across all of those? The most important thing, I think, to kind of deal with all of these issues that you could honestly spend years of your life trying to solve perfectly, go down so many rabbit holes, is make sure you measure a meaningful real world baseline and then aim to beat that. And when you beat that baseline, when your AI is robust to any problems that you've identified, then you know you're good. So one example here would be to measure kind of how accurate are humans in making repair decisions. This is kind of related. Life is a lot easier when you choose the right metric, and also related to thinking about the end user. Kind of when you build an AI, you want to think, how am I going to help the end user? Do I want to save them time? Do I want to save them money? Do I want to accelerate humanity towards the singularity? And kind of depending on what you want to optimize for, you should build your machine learning system to optimize for that. You should build your machine learning system so that it's kind of, it makes as few unacceptable errors as possible. And you can kind of define kind of which sort of errors and mistakes you can sort of accept. So things that it might be like gray areas, or just kind of like human judgment items, things that could go sort of either way. And some things which are like seriously wrong, that you can never really make those sorts of mistakes. You also need to understand the biases kind of in your data, in the decision-making process, and make sure that your AI is robust to those. And then finally, don't forget to measure your baseline, because through doing this experiment, you learn a lot about kind of the notion of acceptable and unacceptable errors, and also biases. So that's kind of, I think those are, I guess, like my top 3 tips on how to build an AI product that delivers a lot of value and kind of thrives in a commercial setting. You've got to find where you want to have impact. You have to define really narrowly what benefit you want to bring. You have to set yourself very specific goals. Secondly, you want to measure a meaningful baseline. So this could be, how good are humans at the task? If there is another system in place at the moment, kind of how accurate is that? You have to think about sort of, what are the value drivers here, whether it's money, whether it's time, and you kind of have to form your baseline experiment in terms of those value drivers. Then you need to construct an AI that delivers your impact. This bit's very important. If you want to build an AI, try not to forget this one. Then beat the baseline. You keep building your AI, you keep working on it until it's robust to everything that you want it to be robust to. And then, deploy a commercially viable AI in real life. This is what we do at Tractable. We have deep learning. It really works. Trust me, I've built it. Along with many other people in the research team. We have a lot of funding. We've tapped into $1 trillion industry. We're deployed in 13 countries and processing over $1 billion of claims. And most importantly, the impact that we have is that there are hundreds of thousands of people who are now that's the impact that I've always wanted to have as a scientist in the world. And I think it's really amazing that I can have that impact at Tractable. Also, if you're interested, we are hiring for many different roles across research, also across engineering. So just send me an email if you're interested. I think that's all from my talk. I can go to the Q&A now. So I have one question saying, what is our revenue? It's very good. I don't think I can give you an exact number right now. So sorry about that. But we are working with some of the kind of top 40 insurers in the world. We are operating across like 13 different countries. We have many customers who buy kind of multiple products from us, so we're kind of constantly upselling as well. And I think that is that's very cool. I think, are there any other We have a question here. So what projects or advancements are you most excited about with a view to 2021? So something my research team is working on right now is how can we find new verticals within the car insurance industry space beyond just kind of estimating and also fraud detection in kind of I guess, writing an estimate from the body shop. And so right now I'm exploring, where do we go next? Do we go, for example, do we do underwriting? Do we go to like salvage bidding? Do we explore, say, rental vehicles? And it's all about thinking, what is the next move? Okay, we've got another one. Do we partner with a vendor who provides parts cost? Yes, so we operate in many different geographies. Obviously, to write accurate estimates, you need to like partner with official vendors for parts prices. So geographies that we move into, we do make sure that we have kind of good parts data, and we have, yes, partnerships with appropriate parties. How many companies went into production with your solution? Gosh, I think I don't have the number off the top of my head. We're in 13 countries. Some countries we are with kind of multiple different companies. So yeah, I would say probably my rough guess is probably over 20. And I have one. What is the most exciting part of Tractable? That's a cool question. So for me, I think the most exciting thing is kind of how fast growing Tractable is and how sort of dynamic and how quickly expanding we are. So we're constantly like moving into new geographies, constantly getting new customers. And that's very exciting. Like, I'll be working on one project 1 month, a couple of months later, I'll be working on something completely new. So there's always so many opportunities to kind of like challenge yourself, to kind of move up in your career. Kind of in the space of 2 years, I went from research intern to research lead. So in terms of kind of career development, this is amazing if you want to progress quickly. So I just think, like, because it's so fast moving, so fast growing, it's a really exciting place to be. Oh, I have one question here on, so you have to cope with poor lighting, unlabeled images. For example, images could be like the back or the front of the car. That sounds hard. Yes, it is. I think this is one of the reasons why solving the problem of like auto damage appraisal is so much harder than things like, for example, like dog and cat classifier, because there are so many different conditions that you need to be robust to. And there's so many, yes, so many things that could go wrong when you're taking images, because we have our app in the hands of the policyholder. We guide them on how to take photos, but there's no guarantee that they'll take the photos in the correct way. So it's a lot of work. So we do kind of have a team in-house that helps us with kind of labeling data, which is brilliant as a researcher. So we can get help from that if we need it. But a lot of it is kind of, we have to identify these problems in our data. We need to learn to detect them automatically, and we need to make sure our AI is robust to them. We need to make sure our AI can tell if images are good enough, and then if they're good enough, that it can make a proper damage assessment. Okay, what strategies do we use to correct flaws as we identify them with the AI in production? So this is a really important project that I've been kind of personally working quite a lot on over the kind of past months, over the past year, in how do we set up this, like, a very robust feedback loop. The most important thing is to ensure we have a way to get good feedback about the AI. So this can be through internal auditing, it could be from direct feedback from our customers. And we need to make sure we have a way to evaluate that allows us to basically like pick out problems and make sure that if we see a problem, we can measure how kind of problematic it is in a statistically meaningful way. And so I think kind of collecting that data is the most important part. And then that kind of informs how basically, like, either if it's sort of like a quick problem that we can fix it in production right away, if it's I guess kind of a more like sort of fundamental and more difficult sort of machine learning issue, then we put that into our research roadmap and then make sure in the next iteration of the models we develop, we solve that. So we're good in production. Okay, so what is the size of library of damaged car pictures needed to build an algorithm that recognizes if the car has damage or not? So I guess this could specifically refer to, say, like if there is, yeah, basically whether it's damaged or undamaged, or it could, I guess, kind of refer to like how many images do you need to make an AI estimate. I think the answer to both is you need a lot, because there are so many different kinds of cars, there's so many different kinds of damage. You need to give that AI enough experience so that it's kind of robust to everything. And so our library of images, I think, is about 300 million plus. So we have a lot of images. Our AI has seen pretty much every sort of way you can like crash a car in this world. Which I think is one of the reasons why our AI is such like a leading technology in this field. And then I have one, how do we pre-process images before constructing neural network? What tools, languages, or packages are you working with? So I'm not sure I can give you the exact details. What I can say is pre-processing images is very important, and it's very important to pick a way of doing so that is kind of relevant and sort of reflects like how a human would essentially process those images, if that makes sense. One example here is sometimes if you are doing computer vision problem, you might want to kind of crop your image to make it into a square of certain size. Obviously, if you're doing that with damage assessment, then you could just miss out some important stuff on the side. So you've got to make sure you're pre-processing. Don't just follow kind of what you find in like GitHub repositories. You always need to think like, is this appropriate for the problem I'm trying to solve? Okay, how did we acquire 300 million images? That's a good question. So we partner with insurers across the world. When we form partnerships with them, they use our products, and also in exchange, we use some of their kind of anonymized data, which I think is very fortunate. I think the business team did a really good job of like ensuring we have a lot of diverse data from insurers across the world. Kind of, what is the biggest barrier that I've observed recently in commercializing AI in the insurance industry? What is critical to consider here? So one problem I've been tackling right now is how do you get humans and AI to work together? And kind of, you have an AI system, it provides some sort of output, and that output is used by humans. How do you, if you're for example working with a motor engineer or adjuster, how do you ensure that they actually use your AI decisions to help them in their workflow, and that they don't just kind of go through their same workflow kind of as before, and sort of ignore the AI's output? Because I guess the purpose of our AI is to kind of make fast, accurate decisions, and also to assist motor engineers when they need it. So kind of understanding, I guess, how humans and AI can work together is a very important thing that I'm focusing on right now. Okay, what kind of damages does our solution detect best? What kind of damages doesn't it do well? What percentage of total damage per customer does it handle? So our AI is very good at damage that you can see, which I guess is not surprising. So if you drive into a wall, it's very good at that. If you scratch against a post, it's very good at that because you can see it. There are other kinds of damages, for example, like flood damage, hail damage, which are a lot more difficult, especially like hail is often like visually, you can't tell, a human can't even tell by looking at images of the car. And so this, it's kind of, you can't really build a computer vision model to do a non-visual task. So this is something we're thinking about right now, is how can we kind of incorporate additional, I guess, non-visual things into our products. Is our product subscription based? Can you say what is the fee a company has to pay and what does it depend on? So to be honest, I don't think I can say that right now. Unfortunately, I think, yeah, if you're, whoever asked this question, if you're interested, please like get in contact with me and I can like link you up to some of the people in the sales team. And yeah, you can talk further about that. Does our solution work in any geography? So it works in every geography that we've tried. So if we would go to Antarctica, I couldn't guarantee it's going to work there. So we have very like diverse proprietary data set from essentially like North America, kind of Europe and Asian kind of data sets. So we can cover pretty much everything in geographies there that we've worked in. That being said, there might be, for example, if there are some completely like different, like visually different cars somewhere else in the world, or something like, I don't know, like a forklift truck that is like not within the scope of what we do right now, then maybe that will be more difficult for the AI. But I think kind of, to be honest, I feel that the data set we have right now covers pretty much any kind of car you can see and covers such a diverse set of repair methodologies as well, that I expect that it should be able to work even in kind of new unseen geographies. I think that's all the questions, unless anyone else has anything else. I think, yeah, I guess if that's all, then yeah, thank you very much for attending. And yeah, just if you're interested in hearing more, feel free to shoot me an email and I'll be more than happy to talk more. Yeah, cool. Thank you very much, everyone.